please open to page 267 in your student journal. We are going to continue graphing quadratic equations with our third and final form, and this is known as intercept form. Intercept form is going to make it very easy for us to find our X-intercepts. X-intercepts are going to be where your graph crosses the x-axis. For X-intercepts, the y value is always 0. So if we have intercept form, the X-intercepts are always the P and the Q values. And we will see that in a more specific example. The axis of symmetry is going to be halfway between those intercepts. The easiest way to find that axis of symmetry then is to add the X-intercepts together and divide by 2. Same as it has been for vertex form, standard form, and now intercept form. If that A value is positive, our graph opens up. If our A value is negative, our graph is going to reflect and it will open down. Now I know, just showing the basics of intercept form, there's A's, there's X's, there's P's, there's Q's. Let's actually go ahead and do some examples where we will find all these different pieces with actual numbers in place. So let's go ahead and turn to page 269 in our student journals, and let's look at question number 9. Now you might be thinking, Miss Golly, that doesn't look like intercept form. Intercept form, it had 2 sets of parentheses. This looks like standard form. And you're very right. In order to get standard form into intercept form, we're going to use factoring. Factoring, remember, we want to find 2 numbers that add together to get us -3 and multiply together to get -10. 2 numbers that multiply to give us -10, same 2 numbers add to give us -3. So what I can think of is a -5 and a +2. If I multiply -5 and +2, I get -10. If I add -5 and +2, I get -3. So now after I factor, now I have intercept form. We see those 2 sets of parentheses. Now we can use that to find our intercepts. In order to find our intercepts, remember, X-intercepts, the y is 0. So if I put 0 in for y, now this becomes a question very familiar to us from chapter 7, which was in last trimester. If I put 0 in for y, that means I want to figure out what can I put in for x. So x minus 5 will equal 0, and x plus 2 will equal 0. Simple little one-step equations to solve. My x is 5. My other x is -2. Now remember, in order to get these values, we put 0 in for y. So now I already have 2 points on my graph without doing a ton of work to get there. So now you might be thinking, Miss Golly, every time we've graphed vertex form, standard form, we've always found the vertex. How do I find that? Remember, our graph is symmetric. So our vertex is going to be halfway between those 2 X-intercepts. So what I can do to find the vertex is I can add together the X portion of it will be just by adding together the 2 X-intercepts and dividing by 2. And we do end up with 1.5. You can do 1.5 if you'd like. That's the x value of my vertex. It's also my axis of symmetry. Now, just like we saw in 8.3, once I know my x value, all I have to do is substitute that in for x to get the y value. So I have, and I'll go ahead and switch it to 1.5. 1.5 squared minus 3 times 1.5 minus 10. 1.5 squared, I'm not sure what that is off the top of my head. I grabbed my calculator, and it's going to give me 2.25 minus 4.5 minus 10. I finish off my computation. I get negative 12.25. So my vertex, the x is 1.5, the y is negative 12 and a 4. Axis of symmetry, x equals 1.5. Remember, those two values are the same. So now when you go to graph, I know some of you in 8.3 were struggling a little bit to graph when your vertex had a larger number. So let me show you how we can handle it if our vertex is a larger number. So in this case I have negative 12 and 1/4, so we have to handle that. Let's start by graphing our intercepts. We have 5, 0, 1, 2, 3, 4, there's 5, 0, and I have negative 2, 0. These are X-intercepts. So they need to go on the x-axis. My vertex is at 1.5, and it says negative 12 and a 4. Well, if I change my scale and now I go down by 3s, now I can fit all the way up to negative 15 on my graph. I don't have to try to extend my graph out at all. I can just change my scale, and that's okay. So I go over 1.5 boxes, and I go down 12 boxes, and then just a little bit for a 4. Remember, these graphs for us are just sketches, so we do our best to graph those fraction or decimal points. If you want to draw it in, remember the axis of symmetry cuts right down the middle. So we use our factoring from Chapter 7 to find our x-intercepts. The x-intercepts give us 2 points on the graph. I add those intercepts together and divide by 2. That finds me the x part of my vertex and also my axis of symmetry. Then to find the y value of my vertex, just like in 8.3, I put the x value back into my equation to come up with my y value. If I have my x-intercepts and my vertex, I have 3 points. I have more than enough to make a graph. I just want to do one more example with you. Let's take a look at number 12. Now I do need you to make a small change for me. We want to do 2x squared minus 12x to the first plus 10. So go ahead and make that small change really quick. If you just want to rewrite the whole thing up above, you sure can, if that makes it less confusing for you. And if you want to, guys, I also want to take this opportunity to remind you, your textbook likes to use the function notation, the f and the x in parentheses, or a g or an h, whatever it is. If you want to rewrite that with just a y, that is okay. They mean the same thing. So now let's take a look. We have standard form. I want to get it to intercept form. In order to do that, we want to factor. The first thing you want to do, though, is look for a greatest common factor. Or in other words, is there a number that I can divide all these other numbers by? So if I have a 2, a 12, and a 10, those are all even numbers, so I can divide everything by 2. So now I have y equals, and remember when we factor the number that we divide by, we need to write out front of a set of parentheses. Now if we look just inside our parentheses, now we have our quadratic that looks just like number 9. I have a plain old x squared term, an x to the first power, and then my constant. So now I want to find two numbers that multiply to give me 5, and those same two numbers need to add to give me -6. Be careful, the sign has to transfer. So multiply to get 5, add to get -6, -3, -5 times -1 will give me 5. -5 plus -1 will give me -6. So now I can factor the x squared minus 6x plus 5. We're going to have an x minus 5 and an x minus 1. Now to find my x-intercepts, we put a 0 in for y. And now it looks like a bunch of questions you guys solved in Chapter 7. So when will x minus 5 equal 0? And when will x minus 1 equal 0? Little one-step solve. We're going to add 5 to both sides. And in the second one, we're going to add 1 to both sides. Show as much work as you need on those. Again, just a reminder, we put 0 in for y. Now to find our vertex point. Our vertex is exactly halfway between those x-intercepts. So to find my vertex, add our x-intercepts together and divide by 2. So 6 divided by 2, the x value will be 3. Then to find the y value, I substitute 3 back in for my x. So 2 times 3 squared minus 12 times 3 plus 10. Please note I went back to our original equation when I substituted in to find the other part of my vertex. So I end up with 2 times 9. So 18 minus 36 plus 10. So I get -18 plus 10. My y value will be -8. So my vertex is 3, -8. Axis of symmetry is x equals 3. These two match. So let's go ahead and graph. Five, 0, 1, 0. Again, the x-intercepts, they go on the x-axis. And then for our vertex, -8, I don't want to draw off the paper down here. I just need to change my scale. So I'm going to change my scale to go by 2's. So now I go over 3 on the x, and I go down 4 on the y to give me my -8. I have my 3 points. I can make a nice sketch of my graph. So again, we start in standard form. Watch out for any common factors that you can divide by. Then once you get your nice trinomial with the 3 terms, once you get the nice trinomial, we can use our factoring shortcut. What can you multiply to get the last number? Same two numbers, add to get the middle term. That can factor it very quickly for us. Find our intercepts. Your vertex then will be halfway between your intercepts. Add your intercepts together, divide by 2. That will give you the x value of your vertex and your axis of symmetry. then substitute back in to get the y value of your vertex. Also, your x-intercepts, one final thing, these are often referred to as the zeros. So if you're asked to find the zeros, that's the same thing as finding the x-intercept, same process. So now go ahead and try out your progress check. You can use any of these notes you want on your check.